Hello, everyone. So the third chapter of the book that we'll be using does make reference to energy in this particular chapter. If we were able to actually go a little bit more in depth and be able to cover a few more topics, we would actually be discussing energy in this course. Unfortunately, based on time constraints, we're not really going to delve too deeply into understanding the energetic relationships in chemistry. However, one measurement that does reflect the energy of a system that we will be using throughout the year is the measurement of temperature. All right, now, temperature happens to be a reflection of the kinetic energy of the particles in a system. So the more quickly particles are moving, then the higher their kinetic energy, the higher the temperature of that particular system will be. The slower particles are moving, then in that particular case, then the lower the kinetic energy and the lower the temperature will be. But we're not necessarily going to get into that relationship so much, but we will need to understand the units and the scales used in measuring temperature very well. And so from previous classes in science, you might recall that there are essentially three main temperature scales. There's the Fahrenheit scale, there's the Celsius scale, and there's the Kelvin scale. For the first part of this tutorial, we're going to really focus primarily on relating Fahrenheit and Celsius to each other, and then later on in the tutorial, we'll come back and we'll talk about the relationship between Kelvin and those two temperature scales. But for now, let's just focus on Fahrenheit and Celsius. Now, what you have here in this particular figure is a diagram of thermometers, essentially, that are scaled with each of those temperature scales that we've been discussing. Now, if we refer to the Fahrenheit and Celsius thermometers, we should come up with two important observations right off the bat. The first of those is that the temperature scales actually do not begin, if you will, at the same point. What we have in these beakers is boiling water. And as it turns out, it's the behavior of water that controls the reference points on the temperature scale. So at 32 degrees Fahrenheit and at 0 degrees Celsius, that is the freezing point of water, which I'll represent using this abbreviation TF. Now, if we consider the boiling point of water, well, water boils at 212 degrees Fahrenheit, but at 100 degrees Celsius. So this is the boiling point, or TB, of water. Now, right off the bat, we can see that the starting points of the scales are different from each other. And so when we convert, so when we're considering converting Fahrenheit to Celsius or Celsius to Fahrenheit, then one thing that we have to keep in mind is we have to correct for the different starting points. So in order to do that, what I would need to do is notice that for the freezing point of water, that reference temperature in Celsius is 0. For Fahrenheit, it's 32 degrees Celsius. For me to correct for that difference in starting point, if you will, I will have to either add or subtract. Make that a little neater. I'd have to add or subtract 32 degrees Fahrenheit. So if I'm going from Fahrenheit to Celsius, I would subtract 32 degrees Fahrenheit. If I'm going from Celsius to Fahrenheit, then I would have to add 32 degrees Fahrenheit. Now, the other thing that we need to keep in mind and correct for when we're doing conversions between the Fahrenheit and Celsius temperature scales is the number of degrees between the boiling point and the freezing point of water. Since the freezing point of water is 32 degrees Fahrenheit, but the boiling point is 212 degrees Fahrenheit, that's a difference of 180 degrees Fahrenheit. Whereas for the Celsius scale, basically the freezing point of water is 0 degrees Celsius, but the boiling point is 100. So basically between those two reference temperatures, there are 100 degrees Celsius. And so in order for us to correct for the difference in the size of the degree for each temperature scale, then we're going to have to do that employing a ratio. So we're going to have to use a ratio to correct for the difference in the size of the degree. Okay, and so that would mean I'm going to have to either divide 180 degrees Fahrenheit by 100 degrees Celsius, or the reciprocal, 100 degrees Celsius over 180 degrees Fahrenheit. So let's take a look at a couple of examples of temperature conversions between these two temperature scales. Now, the book presents you with a formula, okay? And the formula that you get in the book is the following. Say, for example, in this example problem, all right, we're going to convert 70 degrees Fahrenheit to degrees Celsius. In the book, they're telling you that if you want to calculate a degree Celsius temperature, then you take the Fahrenheit temperature, subtract 32, and then you're going to divide by 1.8. Now, you could memorize this formula, or the other way to think about it is use the dimensional analysis that we've talked about before. All right, so let's take that approach so you can actually see it in action. I have a starting temperature of 70 degrees Fahrenheit. Now, remember that I need to make these two corrections in order for me to pull off the conversion successfully. Now, if I consider the first of those corrections, all right, since I'm going from a Fahrenheit temperature to a Celsius temperature, then that means I have to subtract 32 degrees Fahrenheit. And so, since my given information is already in degrees Fahrenheit, then I want to pull off that subtraction right now. So I'm going to first take 70 degrees Fahrenheit and subtract from it 32 degrees Fahrenheit. Okay? That's going to give me a difference in units of degrees Fahrenheit. Now, I also have to convert from degrees Fahrenheit to degrees Celsius. Well, again, we've discussed that before. That means I'm going to have to apply one of these two conversion factors, and I'm going to use the units to help me. Now, here, if you notice, since I have degrees Fahrenheit in this difference term that I started the problem with, in the numerator of the initial setup, then I need to have degrees Fahrenheit in the denominator of the conversion factor so that the unit of degrees Fahrenheit will cancel. And then the degrees Celsius should be up on top. And our equivalence, or our ratio, if you will, is that there are 180 degrees Fahrenheit over 100 degrees Celsius. So if you take a look at what we reasoned out using dimensional analysis, what you're going to see is that it's essentially this formula anyway. I'm subtracting 32 from the Fahrenheit temperature, and I'm dividing by 1.8. If you take a look at this ratio and actually factor out a factor of 10, you'll get 1.8 in the denominator. So if I go ahead and do this math, what I'm going to get is a temperature of 21.1 degrees Celsius. But since I started the problem with one significant figure here, then I really should round this to 20 degrees Celsius. Let's try another one going in the opposite direction. So I'm going to go and convert 70 degrees Celsius to degrees Fahrenheit. So I'm going to take the same approach, 70 degrees Celsius. Now if you notice, in this case, I'm going to need to add 32 degrees since I'm going from Celsius to Fahrenheit. But I don't want to do that addition now because I'm not yet in units of degrees Celsius. And so what I'm going to need to do is use my conversion factor, where I'm going to use this ratio or that ratio to change to units of degrees Fahrenheit. So that means I have to take the degrees Celsius, convert to degrees Fahrenheit. My degrees Celsius here is in the denominator, which cancels in that one, which is in the numerator. There are 100 degrees Celsius for every 180 degrees Fahrenheit. Now that I'm in units of Fahrenheit, now I can go ahead and add 32 degrees Fahrenheit to this. And so if I do this math, I end up with 158 degrees Fahrenheit. Now, if you compare that to the formula they give you in the book, the formula they give you in the book is the following. They say that you're supposed to take 1.8 and multiply that by the temperature in degrees Celsius, and to that you're going to add 32 degrees Fahrenheit. Well, if you check what we reasoned out using the dimensional analysis, this, if I actually factor out a factor of 10, would come out to 1.8. I'm multiplying it times the temperature in degrees Celsius, and I'm adding 32, like the formula tells me to. So even if you memorize the formula or you use the dimensional analysis, you'll end up with the same thing. Now, as it turns out, converting between Kelvin and Celsius is actually a much easier proposition, because if you notice, water will freeze at 273 Kelvin but boil at 373 Kelvin, which means that there are 100 kelvins. Notice that there's no degree symbol, it's just 100 Kelvin. There are 100 kelvins in the same range of physical behavior where there are also 100 degrees Celsius. So I don't have to actually correct for the size of the degree because the degree Celsius and the Kelvin are the same size unit. But I do have to correct for the difference in starting point. So what that means is if I'm going to go from degrees Celsius to Kelvin, I just add 273. Or some books will even list it as 273.15. If I'm going from Kelvin to degrees Celsius, then I subtract 273.15. So if I wanted to convert 250 Kelvin to Celsius, I would subtract 273.15. And if I do that, then I end up with negative 23.15 degrees Celsius, or, since I have two significant figures here, that would be negative 23 degrees Celsius. If I wanted to convert from degrees Celsius to Kelvin, then if I'm starting with 55 degrees Celsius, then I'm going to add 273.15, and that's going to give me 328.15 Kelvin, or if I'm using the rules of significant figures, this should be 328 Kelvin. Okay? The one thing you have to keep in mind, though, is if you are given a temperature in degrees Fahrenheit and you're asked to convert to Kelvin, there is no direct relationship between degrees Fahrenheit to Kelvin. So if you had a problem where you had to convert from degrees Fahrenheit to Kelvin, what you're going to need to do is convert from degrees Fahrenheit to Celsius, like we practiced on this slide. And then you would have to, once you have the Celsius temperature, then go ahead and convert to Kelvin from there. And vice versa. If you're asked to go from Kelvin to degrees Fahrenheit, then you have to go from Kelvin to degrees Celsius, and then using the procedure we used for this problem, you'd have to convert from degrees Celsius to degrees Fahrenheit as necessary. So try some of the conversions I gave you for the follow-up assignment. Please complete that assignment totally, and then we will come in tomorrow, try some additional examples. I'll answer any questions you might have, and by all means, if you have a question or a concern, email me, or if not, speak to me in class tomorrow. I'll see you guys. Have a good night.